Alright, so I've created a packet tracer file here, and so there's two routers, a switch and a PC. I've also got a notepad file with basically just a little few hints for myself and also some commands so I don't have to do all that typing. And you've probably watched me make typos enough that this has had all those typos edited out. And so basically when it comes to switching, go to the CLI, EN, and so of course when we were talking about Ethernet, we were talking about some of the settings we can put on an interface. And so we'll go to, might actually just do that. So again, save myself a bit of time. So now I'm in interface G01. And so the reason I chose gigabit because it's got more speeds available and so a few more options to look at. And so, so if I do a question mark, we can have a look at the commands that are available in interface mode for a switch. And so duplex, of course, is one of the things we'll be talking about today. Of course, shutdown, it's a layer 2 device, and so all the layer 2 interfaces are up by default. It's just the layer 3 SVI that's actually shut down. And of course, we'll look at speed, and we'll also look at MDIX, which is a media dependent interface with crossover. So, so we'll have a look at those options. So if we look at duplex, space question mark, we can actually have a look at the options that are available. So of course the default option is auto, and so that of course means it negotiates with the host or the other device at the other end of the cable, and pretty rare would be the device these days that doesn't do full duplex. And so of course it tries the more desirable option first, full duplex. If that doesn't work, it will go into half duplex mode. So then there's speed. If we go question mark here, again, there's the auto option, which is the default. And then of course, because it's a 10 gig, not a 10 gig interface, it's a gig interface, we've got three options of speed. So 10 megabit, 100 megabit, and 1000 megabit. And so, of course, again, auto negotiation is the default option and will normally work quite well. Got a tickle in my throat. And so, yeah, so that basically, of course, we were looking at a fast Ethernet interface that'd only be the 2-speed options. So again, auto will normally do nicely. And so the other one is MDIX. And so that, of course, is the auto detection of what the other end of the cable is using to transmit and receive data. And so basically this has only got two possible settings, on or off. And so MDIX auto means it's on, and so if you want to turn it off, you do no MDIX auto. And so that's basically the only two options available for that. Okay, so I won't actually make any of those settings because I think G01 I've actually got a host hanging, the router hanging off of it, so I won't play around with those settings and screw up that connection. Now, of course, I need to set an IP address for it, so I've got interface VLAN 1 and set an IP address, and of course, because it's a layer 3 interface, it needs to be turned on as well. So I'll actually just do the rest of this config for the switch. And of course, the copy run start will save that configuration. Now, if we look at, if we do show up, not show up, that's on a router, show MAC address table. Now, nothing is spoken yet, and so the MAC address table is empty. So what I might need to do first is I'll set an IP address on the host. Now it's .10 on the host, 192.168.1.10. The router is going to be 1.1. While I'm in the dialog, And so now, well, there's only two items that are addressed at the moment. There's the switch and there's a host, so I might as well just ping the switch. 192.168.1.2. And so, of course, and these are sent out an ARP request, and for some reason, at least on packet tracer, switches are a bit slow to respond to ARP requests, so you often get a packet or two lost, but that did seem to work. Now, on a Windows machine, and this is pretending it's Windows, ARP-A will actually display the ARP table for this host, and so it's only spoken to one other host, the switch, and so here is the switch's MAC address, and so the host now knows that. So when I sent ping, it would have actually gone, okay, well, that's the IP address, I don't know the MAC address. This is Ethernet, I need to know the destination on this network to talk to that host. And so send out an ARP request saying, hey, who has the IP address of 192.168.1.2? The switch would have replied saying, hey, that's me, here's my MAC address. And that's how this host learnt it. So now if we go back to the switch and we do that show MAC address table, it now knows about the host and it's plugged into fast Ethernet 01. So that's basically how a switch learns it, because the host spoke through the switch, was actually talking to the switch, the switch took notice of the entry. There might be, show ARP might work as well, I can't remember off the top of my head. Yes, it does. And so it actually knows its own MAC address, and it knows the other host. So because this is its own IP address and MAC address, ARP table entries normally time out in roughly 5 minutes, but with itself, of course, its MAC address is certainly not going to change, and its IP address isn't going to change in a hurry because it's static, and so it's actually a static entry in the ARP table. But the host actually has a dynamic entry, and so it's 1 minute old, the entry. If it hits 5 minutes old, it actually won't. It won't be. It will be erased from the ARP table. Now, so the host and the switch are talking nicely, and so show ARP and show IP ARP are options, and of course on the host ARP-A, I've already looked at that. You can also, and which is something I didn't do last time, you can do route print. Should work on this. I mean, I don't remember doing it. No, it doesn't like it. All right, netstat.
Fixing that.
Okay, so yeah, and so you can actually have a look at the routing table of the host as well. And so basically we've got a default route which goes via the router. Now, of course, the router's not running yet, but I told it that, and so that's the entry it's got. And so that is the default gateway. Now that route print will work on Windows. And so that's the actual information there. So this Windows machine has that default route, and that's the gateway for it. So of course this is the Wi-Fi, I'm assuming at the moment. And then it also has a route to the local LAN. So of course it doesn't use the router for local hosts. And then it's got some other entries as well. And so it's actually got some host entries as well in here. Okay, so that's nice. All right, let's have a look at the router. Now, this is the config I was going to apply to the router down here. And so much of this is actually not greatly different to what you've done on a switch up until now. So hostname command, enable secret class, line con 0, password and login. That's all the same. Now, I think the router by default only has, if we do en show run, it only has line VTY 0 through to 4. But if I do this 0 through to 15, it will actually set up the extra VTY connections anyway. Service password encryption, again, we've seen that previously, and that was chapter 2. Now, setting IP addresses on a router, because it's a layer 3 device, each interface gets an IP address. And so this is the interface that's plugged into the switch and into the host. And so, of course, that's the address I gave as the gateway to the host. And so that is on the same network as it. Because it's a layer interface, we need to turn it on. They're off by default. And so the no shut will do that. And so then I've given it an address for the other subnet it's connected to that connects it to the ISP. And again, we need to turn that interface on. And copy run start, of course, will save that configuration to the backup or startup config. So I'll just copy and paste that in. And so again, much the same as if you've ever used Linux, no news is good news. So if the command just goes in and goes for the next prompt, there's been no error, all is good. And so as you can see, there are no error messages. There's a no shut, and so we've actually got 2 no shuts there, and so we've actually got 2 interfaces that have come up. As you can see, the green lights now instead of they were red lights before. And so that's all a very happy world. Now if we do show IP route, this router will know the networks it's directly connected to, which coincidentally is there's only 2 networks, and so it's in quite a nice little spot. And so it's got a directly connected network for 0.1 network and another one for 0.2. And so that's all very nice. So let's do some pinging. I might ping the switch again just because I can. Just to refresh it. Let's do the router. That's working nicely as well. And so the other router is 2.2. And I think that will work as well. Might be an ARP request in waiting, but yeah, so that's working as well. So that's working nicely. Now, let's do that ARP -A again on this host. And so it knows the router and it knows the switch. Of course, I pinged 2.2, but because it's on a different subnet, it would have used this MAC address as the Ethernet destination, and of course it would have used 2.2 as the IP destination. All right, so let's have a look at the router. You can actually do show ARP here. And this actually has a few extra entries. Because the router is on multiple networks, it actually has entries for all of the networks it's connected to. So it's got its own one, and again, it doesn't time out because it's pretty much static. The host here just did the ping. It's less than a minute old, so that's got a while to last. Then on the next subnet, it's got its own interface, and it also now knows the IP address of the remote router because this host pinged it, and so of course the router actually had to create the Ethernet packet on its behalf to send it to there, and so it learnt the MAC address of the other router as well. Now, so about the only thing that doesn't have an entry in the ARP table there is the switch, because the switch and the router actually haven't spoken to each other yet, but I can fix that. So now if we do that show ARP, it's also got an entry for the switch as well. So all seems to be happy with the world. And so if we do a show run, we can actually have a look at the configuration that's in there. And so the host name has been set. We've got that enable secret command. We've got the interface configurations, and that shutdown has been removed from them. We've got the line con password with login, and we've got, again, now more than 5 connections. We've got 16 connections for VTY, and they've got a password and login set. So that's a fairly happy thing. Because I did a copy run start, if I do show start, I should get exactly the same thing. And we are. That's all very happy. Now router 2, I think I've called it ISP. If I do en show run, there's not a lot on here. I haven't done any passwords or anything like that. I've just addressed that interface to be 2.2. That's why that ping worked. Another reason why the ping worked is previously I'd actually put in a default route. So IP route and then quad 0 as the destination and quad 0 as the mask, which means 0 bits need to match for this actually to match as a destination. And then the next hop is 192.168.2.1, which of course is this router here, 2.1. And so that's why the ping actually worked. If that default route wasn't there, this router actually would not have known how to reply. And so that's why it worked. So that's pretty much all I was looking at demoing today.